Probability and relative frequency. Here we go. Number one, Jacob performed an experiment with a weighted die numbered 1 to 6. He rolled the die 125 times and recorded the results. Complete the table below. So let's just stop. What in the heck is a weighted die? A die, the thing like you roll when you're playing board games, is supposed to be evenly weighted so that all the numbers have the same probability of showing up. But if the die is weighted, that means that maybe one side is heavier than another side, so it's more likely to land on that side and show a certain number more often than 1 out of 6 times. So frequency is the number of times that number in the row here, so 1, the frequency would be how many times we landed on 1. It says the frequency for 2 is 13, which means out of 125 times, we got the number 2 13 of those rolls. So on 13 rolls, the number 2 came up. That's out of 125. The experimental probability for that column, for that row, I should say, is blank. To find the experimental probability, all we do is take the number of times we landed on that number and divide by the total number of times the die was rolled. So 13 times out of 125 is 13 divided by 125. That is equal to 0.104, which is 10.4%, and that's the experimental probability. So simple. If you have the frequency, divide the frequency by the total number of trials. That's what we call the number of times that we perform this little experiment. 13 divided by 125 is that decimal, 0.104. So that 0.104 is the experimental probability for that instance. Let's do it again for number 4. Number 4, they got 29 times. So what is 29 out of 125? 29 divided by 125 tells us the answer, which is 0.232 or 23.2%. So that is the experimental probability there. The number 6, we got 6 times. 6 divided by 125 equals 0.048. So those are the experimental probabilities for those frequencies that we knew. Well, how do we go backwards? This one tells us the experimental probability, but not the frequency. For the number 3, it says the experimental probability was 0.144. So if the experimental probability is 0.144, which is 14.4%, that means that we got the number 3 that portion of the time. So I'm going to type that probability into my calculator, 0.144, and I'm going to multiply by the total this time, times 125. If I want 0.144 of 125, I type into my calculator 0.144 times 125. When we do that, we get 18. So that means we got the number 3 18 times out of 125. And 18 times out of 125 is 14.4%, or 0.144. Let's do that again for the number 5. The experimental probability is 0.296. So what is 0.296 times 125? Okay, so 29.6% of 125 equals 37. Okay, back to number 1. Well, wait a minute. Number 1 doesn't tell us a frequency or the experimental probability. How are we supposed to figure that out? Easy. We know all the rest of the numbers, and we know the total number of times it happened. There's supposed to be 125 trials. We know all the other numbers, so whatever's left has to be number 1. So if we start with 125, and we take away all the other ones, minus the 13 times number 2 it landed on, minus the 18 times it landed on 3, minus the 29 times it landed on 4, minus the 37 times it landed on 5, and minus the 6 times it landed on 6, that leaves us with only 22 left. We've got 22, and there's only one probability left in the selection box, so we can drop that in there. But if we needed to calculate it on our own, it would be simple. 22 divided by 125 is equal to 0.176, and that's what's right there. All right, here we go to the next one. Number 2, a teacher at a dance academy randomly surveys 150 people on the academy's social media page about their favorite type of dance. The data she collected is shown in the table. So we got 1, 2, 3, 4, 5 different dance types, and the votes received for each one of them. Jazz got 36 votes, hip hop got 48, etc., etc. Based on the data, what is the probability that the next randomly surveyed person on the academy's social media page prefers hip hop? Okay, how many people chose hip hop? 48. out of how many people total? 150. So to find the probability, we do 48 divided by 150. So again, I'm finding the probability of that the person likes hip hop. So far, 48 out of 150 have. So 48 divided by 150 tells us that 0.32 is the portion of people that prefer hip hop. So if we use that to extrapolate to the next person, there's a 0.32 chance that the next person likes hip hop also. And 0.32 is 32%. Number 3, Mike is planning a vacation. He has narrowed down his choices to 3 types of vacations: coastal, rural, and urban. He uses the spinner shown above, which is evenly divided into 3 sections, to randomly decide which type of vacation to plan. If he spins the spinner 150 times, predict the number of times the spinner would land on the urban section. Well, the urban section is just as big as the other 2 sections, so there's a 1/3 chance it'll land on urban, 1 out of 3. So we would expect it to land on urban 1 out of every 3 times. So what is 1/3 of 150? If I want to know what 1/3 is as a decimal, I could just do 1 divided by 3. And that's equal to 0.3 repeating. If I multiply that by 150, I get 50. So my best guess is 50. Now B says the spinner would land on the urban section exactly 50 times, but that's a bad answer. The correct answer is A. The spinner would land on the urban section roughly 50 times, but probably not exactly 50 times. 50 is going to be the best guess that we have, but we wouldn't be surprised if it was 49 or 48 or 47 or 46 or 51 or 52 or 50. Anything close to 50 makes sense. But if it was way less than that or way more than that, then we would have cause for alarm. We would say, hey, there's something wrong with this spinner. It's not really being even. So 50 times is our best guess, but that doesn't mean it's going to happen exactly 50 times. It just means that's the number that the results should be close to. Number 4, on his website, the owner of a sports academy randomly surveyed visitors about their favorite outdoor sport. The data he collected is shown in the table. So we got basketball, soccer, baseball, tennis, and golf, and the number of votes they all received. Use the data to complete the sentence. Round the answer to the nearest 1/10 of a percent. The approximate probability that the next surveyed visitor will choose baseball as his or her favorite sport is what? How many people chose baseball so far? 76. Out of how many total? Ooh, it doesn't say. So we're going to have to add up all the votes to get our total, because we need a total number of votes to find the percent of people that chose baseball. So let's go ahead and add these together. 83 plus 62 plus 76 plus 48 plus 31 is 300. So 76 out of 300 people chose baseball. 76 divided by 300. So the number of people that chose baseball is 0.25, 3 repeating. If I was going to turn this into a percent, I would move that decimal place over 2 spots, which is just the same as multiplying by 100, and I would get 25.3 repeating percent. But I need the closest 1/10 of a percent. So that number right there, I either keep it a 3 or bump it up to a 4, and I'm going to keep it a 3 because the next number is less than 5. So the answer is 25.3%. Number 5. As a promotion, a clothing company sent out an email with a link where the recipients have a 1/20th probability of receiving a 40% off coupon. Otherwise, they receive a 5% off coupon. If 460 of the recipients click the link, which of the following is the best prediction of the number of recipients that received a 40% off coupon? So 1/20th of them are going to get that 40%, or that's our best prediction, about 1/20th. So 1/20th of them, how many people clicked it? 460. So I want to know 1/20th of 460. So 1/20th times 460. 1 divided by 20 is 1/20th, times 460 is 23. So there's our answer, 23. Number 6, Merle has found that the probability of randomly drawing a bag of green tea out of a box of assorted tea bags is 3/7. If Merle draws 28 tea bags out of the box, which of the following is the best prediction of the number of tea bags that will be green tea? So 3/7 of 28. You can use your fraction skills for this, or you can use a calculator. 3/7 is 3 divided by 7. So 3/7 is this crazy decimal. We will expect this portion of the time to get the t that we're looking for here. So we expect it to be this portion of 28. So we say times 28. And we get our answer, which is 12. Now I told you that you can use your fraction skills. Here is what that looks like. If you expect to get the green tea 3/7 of the time, then you want to calculate what is 3/7 of means times in this case, 28, which is the same as 3/7 times 28 over 1. Now, multiply these fractions together and you'll get your answer. Now, a lot of you like to multiply across the top and across the bottom and simplify, so we'll do that first, even though that's not how I like to multiply my fractions. But 3 times 28, 3 times 20, 60, 3 times 8 is 24, so that's 84, over 7 times 1 is 7, and 84 divided by 7 is 12. The way I like to multiply my fractions when I have numbers that I can simplify is I simplify first. I see 28 and 7 both divide by 7. 28 divided by 7 is 4. 7 divided by 7 is 1. So this turns into 3 over 1 times 4 over 1, which is just 3 times 4, which is just 12. So either way, you get 12. Number 7, according to a survey, the probability that a subscriber of an online book club would prefer reading a nonfiction book over a fiction book is 22%. The book club has 21,121 subscribers. Approximately how many subscribers would prefer reading a nonfiction book? So the nonfiction book crowd is 22% of them. 22% in a calculator is 0.22. That's the decimal equivalent of 22%. We want to figure out 22% of 21,121. So we do 22% times 21,121. So 0.22 times 21,121 gives us our answer, which is 4,646.62. So we're going to choose the number that's closest to that, which is rounded to the nearest whole person, 4,647. Number 8. A ticket brokering company is randomly distributing tickets to customers who pre-ordered tickets for an upcoming concert. Out of the first batch of tickets sent to pre-order customers, 25 are in row 7, 22 are in row 8, and 8 are in row 9. Which of the following is the best prediction of the number of tickets in row 7 in the next 33 tickets sent out? So how many tickets right now are in row 7? 25 of them. Out of how many tickets total? Well, 25, 22, and 8. Add those together and you get 55. 22 and 8 is 30, because 22 seats are in row 8 and 8 seats are in row 9. So if you just ignore the row numbers for a second, because you might be confused by those other numbers, we have 25 tickets here, 22 more tickets, and then 8 more tickets. 8 plus 22 is 30, plus 25 is 55. So 25 out of 55 are in row 7. So 25 divided by 55 is that percent. So 0.45 repeating. You could also write it as a fraction and simplify it. 25 out of 55 both divide by 5. So 25 55ths will simplify. I'll go ahead and do that for you. So again, 25 out of 55. Both of these divide by 5, and you get 5/11ths. So the probability of row 7, and this is probability notation that I'm writing here, it's capital P, and then parentheses, you put the event that you want to know the probability of. So the probability the next ticket is in row 7 is equal to 5/11ths. But the decimal equivalent of 5/11ths is 0.45 repeating, 0.454545. And I write 0.45 repeating with the little repeating bar. Now, which of the following is the best prediction of the number of tickets in row 7 for the next 33 tickets out? Well, we want 5/11ths of 33. Again, I could do that with my fraction work. 5/11ths of 33 is 5/11ths times 33. But if you've already got the decimal in your calculator, all you have to do is hit times 33. It's the same thing. And when you do that, you get 15. And if I do it up here, 33 and 11 both divide by 3, so it's 5 times 3, because 5 over 1 times 3 over 1, and 5 times 3 is 15. So either way, you're going to get 15 times for something that has a probability of 25 out of 55. Now, this is kind of silly because you would assume that the more tickets, there's a limited number of tickets in row 7, so the more tickets that come out in row 7, the fewer there are left, but that's not what it's really going for here. Number 9. Ken is conducting an experiment in which he spins the arrow on a colored spinner 200 times. He records the experimental probabilities of landing in each colored section of the spinner. So we got the section landed on, red, blue, green, or purple, and the probability here. Find the frequency of landing on a given color. So purple, we got purple, or Ken got purple, 0.135 of the time, that portion of the time. That's the same as 13.5%. What is 0.135 times 200? It's this portion of 200. So I take the portion and I multiply by 200 to figure out what that is. So 27. So you got purple, 27 out of 200 times. So again, we had 27 times out of 200 gives us our 0.135, which is the probability. So if they give you the probability, you just multiply by the total number of trials, which was 200, and it'll tell you the frequency, which was 27. Let's do that again for green. Green was 0.220, which is the same as just 0.22. I don't need that extra zero on the end. That times 200, and you get your answer, which is 44. Blue was 0.410. So 0.41 times 200 is 82. And last but not least, red was 0.235 times 200. And you get 47. Number 10. If the die above is rolled 300 times, predict the number of times it would land on an even number. Now, we assume that this die is fair, that every number has the same chance of coming up. So we would expect that the even numbers have the same chance as the odd numbers, because there's 3 even numbers and 3 odd numbers. So the probability that it lands on an even number is 3 out of 6, 3 divided by 6, which is, of course, 1/2, 0.5, 50%. So we would expect 50% of the time that it lands on an even number. So what is 50% of 300? 0.5 times 300 is 150. So there's 150. So we expect 150. And that's what A says. The die would land on an even number exactly 150 times, but that's a bad answer, because it's probably not going to be exactly 150 times. That's just our best guess. It's the closest number that we should guess. It's our best guess. But the fact that it's going to be exactly 150 times even and exactly 150 times odd, that's not very likely. So we just want to say that 150 is our best guess. Which one says that 150 is our best guess? B. The die would land on an even number roughly 150 times, but probably not exactly that number. And that is it. Good luck. Make sure you flip through the lesson here. Check out all the examples that there are. There's plenty of written examples that are just like the problems you have to do, and a video to watch, as always. That's it.